Hello class! Today what we're going to talk about is how to solve non-right triangles. We're going to do this using the law of sines. Okay. So if you remember, solving a triangle means to find all of the side measures, all of the angle measures. Okay. And we've done that with right triangles using SOHCAHTOA and using the inverse sine and inverse tangent and inverse cosine to get the angles. What we're going to do today is solve non-right triangles. Okay, so we're going to still be using sine and cosine and tangent and all that, but we're going to be using these in non-right triangles. Usually what we're going to use is pretty much just sine. We're just going to use the law of sines in this. So first, what is the law of sines? So here it is. The law of sines says that the sine of angle A divided by the length of side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by the length of side C. So basically saying that the sine over the side opposite that angle is going to be proportional. All right? And that's what we're going to do. We're just going to set up proportions. And you can either do it like this, or you can put the side measures on top and the sines of the angles on the bottom. It doesn't matter either way. I prefer to do this just because it's always the same every time, and I don't have to mess with switching them and remembering which one's on top this time, which one's on this. Always put the sine of the angle in the numerator divided by the length of the side opposite that angle. All right, so notice side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. Okay. All right, so let's do a couple of these. Okay, so we're going to solve this triangle. Notice this is not a right triangle, so it's not just going to be SOHCAHTOA. Okay, what we're going to do is we're going to set up a proportion. Now, for this to work, we have to have one side and the angle opposite that side. Okay, as long as we have that, then we can work this all out. Okay, and then we need either one other side or one other angle. So here we've got this other side. We've got 20 is opposite the 115 degrees, so we've got those two, and then we can figure out angle B, angle C, and side C. All right. So first we have these two, so we're going to set those up, and then the other side we have is 11. That's opposite angle B, so let's go with that. All right. So first we're going to find angle B because we can't figure out anything with C because we don't have anything for C. So sine of B is equal to the sine of A over the side A. All right. So we're going to plug in for this. We don't know what B is, but we don't know what angle B is, but we do know side B is 11. We have the sine of 115 degrees over 20. All right? And then we just cross multiply. Gives us this, 11 sine 115 over 20. Now we do still have to get rid of the sine. So we're going to take the inverse sine. It didn't show you, but that's what we're going to do. We're going to take the inverse sine of all of this. And you just put it straight into your calculator, and it's going to give you approximately 29.9 degrees. Okay, so that's angle B. How are we going to find side C and angle C? We can't set up a proportion because we don't have one of the variables put into it. However, we do now know two of our angles. And if we know two angles, we can find the third because all three angles are going to add up to 180. So 180 minus 115 minus the 29.9, which we just found, is going to give us approximately 35.1. It's not going to be exact because this 29.9 isn't exact. All right, well, it's going to be pretty close. So now that we know angle C, we can set up a proportion like this to find side C. So here we go. And we plug in side C over the sine of 35.1 equals side A, 20, over the sine of angle A, which is 115. Work then, cross multiply and divide. Type that straight into calculator. You can do it just like that. And it gives you C of approximately 12.7. All right? And so there are your three missing sides and angles. And now we have solved the triangle, even though it's not a right triangle. All right? So let's do this. I want you to solve these two triangles, pause the video, work it out, then come back and see how you did. All right, let's see how you did. Those are the missing angles and measurements for triangle 6. And here they are for triangle 7. If you got those both right, congratulations. Good job. You can fast forward to the next little bit. All right? But if not, let's take a look for you. See what we did. Okay, so on triangle 6, first thing, we do have 18 opposite 51. We do have this 17, which is opposite angle C. So we can find angle C first. So we set up our proportion. All right. Cross multiply. Now you have to get rid of that sign, so we're going to do the inverse sign. Yeah, I got it all shown out for you. So we have the inverse sign of 17 sine 51 over 18. And it might be better to work this out, put this in your calculator, and then take the inverse sign of that, depending on how good you are with the calculator. That's going to give you approximately 47.2 degrees. We can take that, subtract that, and angle A from 180. Now that we know two of the angles, we can get our third one pretty easily. We get angle B, 81.8. And then we're going to do the law of sines again. All right, so we plug that in to our proportion. We have sine of 51 degrees over 18. That's A over A. And sine of B over side B gives us this. And there it is, 22.9. Okay, so for number 7, let's see, we have A and A again. So that's our first set of the proportion. And then we have side opposite angle B. So it would be sine B over 13 for the other one. All right, so we have sine 40 over 16 equals sine B over 13. Cross multiply, take the inverse sine of that to get rid of that, and plug that on a calculator, and we get 31.5 approximately. So now we have the measure of angle B. We've already got the measure of angle A up there, so we can subtract those both from 180, which gives us 108.5 approximately, because this 31.5 is not exact. That was rounded off. So this is going to be rounded off. All right. And then we can take that, plug that into our law of sines, cross multiply and divide, and we end up with C is, there we go, C is approximately 23.6. All right. Okay, so all we're doing here is just proportions. It does have sine in there, so we may, on some of these, we're going to have to do that inverse sine, but that's okay. It's still just proportions. Okay, so what about this? Let's see here. Does this one, this is still more of the same, except this time it gave us two angles and a side, but this is still opposite that other angle, so it's not a big deal, right? Set this up into law of sines. Well, first we do have two angles, so we can find that third one pretty easy, just subtracting both from 180, right? But then we've got one side opposite an angle, so we can just do law of sines there. Here we have angle B and side B, so we have 15 over sine 25, and we have A over sine of A, C over sine of C, sine of angle C. And what we're going to do is we're going to take this and we're going to split it up into two proportions. Yeah. So we have A over there, C over here. Cross multiply and divide for each one, and that gives you A equals 26.4, C equals 33.9. And that's it. So not too bad. We're going to do another one. A little bit more application here. Surveys making measurements. He's made these measurements here. He knows that from North Picnic area, East Picnic area, South Picnic area, we've got angles that he's measured out, and he's managed to measure this at 150 meters. Right? But they're going to build a bridge from North Picnic area to the South Picnic area, and they need to know how long of a bridge to make. And they can't really measure that very well going across the lake there. Didn't manage to measure this one, but this one's too long. So, law of sines, right? Got to solve for that distance. But notice we don't have any angles, any sides opposite each other. So that's a problem. However, we do know two angles. And if we know two angles, we can find that third angle. So we can find angle B, which is opposite the 150 meters. All right? And so we do that. we are going to add up those subtracted from 180. So there it is. Angle B, it has a measure of 49 degrees. Now we have angle B and side B, so we can set up our proportion here. Now we're just interested in side C from point A to point B, so we can ignore this right here. And we're just going to do sine of C and side C. So we're just going to do that one. So sine of C, C over sine C equals B over sine of B, right there. And cross multiply and divide, and we end up with C is approximately 72.1 meters. And so now we know how long to make our bridge. Alright, so we can use this for indirect measurement, which is pretty nice. So what I want you to do, work out these three problems. You may need to back up to see the picture for number 10 to see that picnic areas again. Work these out and then come back. Okay, let's see how you did. 8, 9, and 10, that should be what you have. If so, good job, you're done with this video. If not, let's figure out where you went wrong so we can fix it and not make that mistake again. So number 8, we've got two angles. We need to come up with that third angle. We've got two of them, we can do that easy. So we'll do that first, and then we'll do our law of sines to come up with these two missing sides. So first, we're going to subtract those two angles from 180. So the measure of angle C is 66 degrees. And then we're going to set up our two proportions. So there's our proportions. And then we just cross multiply and divide. And we work those out. And there they are. All right. Number 9. Again, we have two angles. We're missing a third angle. This one we don't have anything opposite. So we definitely have to get that first. But that's not a big deal. We just subtract those from 180. Gives us A is 29 degrees. And then we can set up our proportions. So there's our first proportion for B. Here's a proportion for C. Cross multiply and divide. Stick that in our calculator. And there's B and C. Alright. Last one, that's going back to the picture, this here. Well, we've already got this, and that's all it's asking us to do is solve for A. We've already got a proportion right there. So we just got to plug it into our proportion, cross multiply and divide, stick that in our calculator, and we have A equals 187.9. Right? And that is the law of sines. It's not too bad. Just remember, you've got to have one side and the angle opposite that side. As long as you have that and one other measurement, then you can solve any triangle and it's all good. All right. Hopefully that helps, and I will see you next time.